right, so some of you guys wanted to know how to do a tri-hybrid cross. For honors, remember this is extra credit. For regular bios, this is definitely extra credit. So you do not have to watch this if you want, whether you're honors or regular. But anyways, a monohybrid is when you're looking at one trait. Hey, color of flower. Dihybrid, and monohybrid just has 4 squares. Dihybrid's when you're looking at 2 traits at once. So maybe flowers and are your seeds round or wrinkled. Trihybrid, tri means 3. So now we're looking at 3 traits at once. So dihybrids have the 16 squares. Trihybrids have 64. Now you can figure it out using 64 squares. Count them all up. It takes you won't even have enough time to do that during our test. But luckily you don't need to do it because you can do it with a little math. All right, so here's our traits. Yellow's dominant, white's recessive, big Y, little y. Round's dominant, wrinkled's recessive, big R, little r. And tall is dominant, short is recessive, big T, little t. Here are the genotype of our parent plants right here. This one's heterozygous or hybrid for all traits. So that kind of stinks. But this guy's going to help us out because he's homozygous recessive, white flowers. He's also homozygous recessive, wrinkled seeds. And it would have made it super easy if he was homozygous for tall, short, but he's not. So he's heterozygous for tall, short. But this guy's going to help us out. It's going to make it a lot easier. And this one's actually more difficult than the one that's on your test. And this is really not that difficult. All we're going to do is we're going to break it down one trait at a time. So we're going to start with the Ys. We're just focusing on this guy's Ys and this other plant's Ys. All right, so this guy's big Y, little y. So obviously, he can give his big Y or he can give his little y. Those other guys got 2 little y's, so all he's got are little y's. So remember, we can do 2 little y's if we want, but we don't have to. Since these are both the same, we can cross this out. So this one's going to be big Y, gigantic Y, tiny y, so I can really tell them apart. And this one's going to be tiny y, little y, little y. All right, so what are the chances of getting big Y, little y? Oh, I don't like that. Why is it so small? Let's do that. And let's go red. There we go. All right, so what are the chances of it being big Y, little y? Well, it's 1 out of 2, 50%. Another way to put 50% is 0.5. What are the chances of getting little y, little y? Well, that's the other 0.5. So that is going to also be 50%. 1 out of 2 is 0.5. Now you're saying, hey, why isn't there a big Y, big Y? Well, you can't have that genotype because this guy can give a big Y, but this guy over here does not have a big Y to give. So that genotype is impossible. Let me move this guy back where he's supposed to go. And that's close enough. All right, so now we're going to move on to the R's. It's exactly the same as the Y's because this guy's big R, little r, and this guy's little r, little r. So it's, the same thing, just different letters. All right, so this plant over here can give its big R allele or it can give its little r allele. And just like the last guy, this guy's got 2 little r's, so I'm just gonna put 1. I don't need to do it twice. I'm going to scratch this one out. And now, what are the chances of getting big R, little r? There's that one. And little r, little r. So there is no possibility, once again, of getting big R, because this guy does not have a big R to give. That's Mendel's principle of segregation. So once again, big R, little r is going to be just like big Y, little y. 50% or 0.5% chance, or 0.5, that's 50%, but 0.5 is the same as 50%. And it's also 0.5 of getting little r, because 0.5 as a decimal, that means 50%. Move this guy where he belongs. Now you can notice there's 3 different genotypes over here. Well, the reason there is because this one can have big T, because this guy can give the big T, and this guy can give the big T. All right, so this one we're going to have to fill in all the boxes. All right, so this plant over here is big T, little t. Big T, little t. And let me draw it. And this other one's also big T, little t. So we can give the big T allele or the little t allele. All right, now let's just fill in the boxes. Here's the big T that was missing from the first 2 Punnett squares. Here's the big T, little t. Here's another big T, little t. And here's a little t, little t. All right, so now what are the chances? You can see only 1 out of 4 have the genotype of big T. 1 out of 4 is 25%. 25% as a decimal is 0.25. Oh, 0.25. Big T, little t, you can see there's 2 of them. 2 of them out of 4 is 50%. To put 50% in a decimal, it's 0.5. Or you can put 0.5, it's the same thing. Little t, it's 1 out of 4. So that's 25%, and 25% as a decimal is 0.25. All right, so now we found the odds of getting each individual genotypes with just one trait. Well, now the odds, so say the odds of flipping a coin, we all know the odds of flipping a heads would be 50%, 0.5. Well, what's the odds of flipping two heads at once? The odds of flipping two heads at once is it's called the product rule. You multiply the odds of it happening by itself, and you'll get the odds of it happening together. So if it's 0.5 to flip a heads, and you want to flip two heads, it's going to be 0.5 times 0.5. How about four heads in a row? Heads, 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 heads. What are the odds of doing that? It's 0.5 times 0.5 times 0.5 times 0.5. All right, so now it's going to be this stuff. So what are the odds of getting big Y, little y? It's 0.5. What are the odds of getting big R, little r? It's 0.5. What are the chances of getting big T? Big T, it's 0.25. So now I gotta get my calculator out. So the odds of getting this entire genotype is gonna be 0.5 times 0.5 times 0.25. All right, I gotta get my phone ready. It wasn't ready. I should have got it. So 0.5 times 0.5 times 0.25 equals 0.0625. But remember, to put that into how many squares it would be in 60 out of 64, I got to multiply 0.0625 times 64. So times 64 equals 4. 4 out of 64 of these plants will have that genotype. 4 out of 64. And it's not red, but who cares? All right, so let's move on to the next one. What are the chances of getting all these? These are all going to be, this one's all going to be 0.5. 0.5 times 0.5 times 0.5. Let's do that one. 0.5 times 0.5 times 0.5 equals 0.125. Times how many squares there are in a trihybrid cross, which is 64, times 64 equals 8. This is going to be 8 out of 64 on average of those plants. And I don't know why it's small, but oh well, we're going back and forth with this stuff. All right, this one's going to be exactly like the top one. Big Y, little y, big R, little r, it's going to be 0.5 times 0.5 times 0.25. Well, we already did that. So I don't even have to use my calculator. It's going to be 4 out of 64. 4 out of 64. Boom. This one right here, okay, this one's going to be 0.5 times 0.5 times 0.25. That's going to be the same thing again. So that's going to be just like the top one. So that one's going to be 4 out of 64 again. So you're really not doing a whole lot of math because you're usually just repeating a lot of stuff. 4 out of 64. All right, this one, big Y, little y is 0.5. Little r is 0.5. Big T, little t is 0.5. Okay, these are all 0.5. Well, we already did that. We did it right here. So this one's going to be 8 out of 64 again. 8 out of 64. Boom. All right, so now this moves along pretty fast because you really don't have to do much calculating. Little y is 0.5. Big R, little r is 0.5. Big T is 0.25. I'll do it again just to make sure I got it right the first time. But let's see. So 0.5 times 0.5 times 0.25 equals 0.0625 times 64 boxes in a trihybrid gives you 4 out of 64. I was right the first time. 4 out of 64 will have that genotype. This one's 0.5. 0.5 times 0.5. We've done that several times. That's 8 out of 64. 8 out of 64. Remember, this one's actually more difficult than the extra credit one you have on the exam. This is going to be 0.5 times 0.5 times 0.25 again. We've done that several times. It's going to be 4 out of 64. 4 out of 64. It's going to be 0.5 times 0.5 times 0.25. We just did it the last one. Same exact thing. It's going to be 4 out of 64 again. And the last one, it's going to be 0.5 times 0.5 times 0.5. We've done it already. And that is going to be 8 out of 64. Now let's count them all up. I'm going to use my calculator. I'm going to count 4 plus 8 plus 4 plus 4 plus 8 plus. I'm going to count all those up because it should equal 64. If it doesn't, I screwed up somehow. So let's see. All right, so let's see if I can do it in my head. 4 plus 8 is 12. 12 plus 4 is 16, 20, 28, 20, 32, 40, 48, and I screwed up. Crap. Oh, this is how I screwed up. All right, here we go. We missed a couple. There was a few more down. All right, so it's going to add up. That's got to do. I just didn't see these down here. All right, so this is going to be 0.5 times 0.5 times 0.25. Hey, guess what? We've done that like 5 times already. It's 4 out of 64. We'll have that genotype. This guy that's moving back where he's supposed to go. And so it's going to be 0.25 times 0.25, or no, 0.5 times 0.5 times 0.25. And if you do that, and then you multiply it by how many boxes there are, 64, you're going to get 4. Make sure I got it right. Yes, 4 out of 64. All right, now let's add them all up. Let's see if I got them all. All right, I'll use my calculator. 4 plus 8 plus 4 plus 4 is 8, so 8 again, plus 8 plus 4 plus 8 plus 4 plus 8, because 4 plus 4 is 8, plus 8 plus 4 equals 64. I got them all. So boom. If you can do that on the test, you'll get extra credit. And really, this one's more difficult than the one on the test, so I don't think you'll have too much problem with it. All right, if you have any questions, raise your hand in class or just ask me and I'll explain it further. All right, I'll see you next time.